Hey everyone, welcome back. I hope you're all doing well. In this video, we'll cover the final part of our lesson on activity duration estimation. Specifically, we'll learn the PERT method and the parametric method. The PERT method, or Program Evaluation and Review Technique, was developed in the late 1950s by the US Navy for the Polaris missile program. It is used to improve scheduling accuracy, especially for large and complex projects with high uncertain job conditions. The PERT method relies on three key estimates to calculate activity duration: the optimistic estimate, the most likely estimate, and the pessimistic estimate. The optimistic estimate is shortest possible duration for completing a task. It represents the best case scenario, where everything goes as smoothly as possible with no delays or issues. The most likely estimate is based on what is most probable to happen. It considers the usual obstacles, but assumes that things will generally go as planned. The pessimistic estimate is the longest possible duration, factoring in potential challenges that could arise during the task. It represents the worst case scenario, where things go wrong or unexpected delays occur. To gather data for these estimates, project managers often rely on expert judgment, historical records, or industry benchmarks. This ensures that the calculations are based on real-world insights rather than just assumptions. The PERT calculates duration using a weighted average of the three estimates: optimistic, most likely, and pessimistic. The estimated duration is optimistic plus 4 times the most likely plus pessimistic, all divided by 6. The most likely estimate is weighted most heavily, while the optimistic and pessimistic estimates reflect the best and worst case scenarios. This helps account for the possible outcome with the extreme conditions. This diagram shows a typical distribution of construction duration data. It is often right-skewed, meaning there is a long tail representing rare occurrences of extremely long durations caused by unpredictable events such as adverse weather, supply chain disruptions, regulatory changes, or unforeseen complications. These factors can cause significant delays, making the pessimistic estimate, worst-case scenario, much longer than the most likely estimate, sometimes doubling or even tripling the expected value. For example, in this case, the pessimistic estimate is 6 weeks, while the most likely estimate is only around 2 weeks. However, such extreme situations are rare, so their occurrence is typically low for most tasks. Given these uncertainties, it is crucial to adopt a more conservative approach in duration estimation. The weighted average in the PERT method takes into account the pessimistic estimates, resulting in a more conservative estimate than the most likely value. This helps project managers better prepare for potential delays and manage risks more effectively. Let's apply the PERT method to estimate the activity duration in this example. We need to calculate the total duration for the entire process, including designing, fabricating, and delivering a major piece of equipment. Based on historical data, we have the following 3 estimates. The optimistic estimate is 14 weeks, the most likely estimate is 19 weeks, and the pessimistic estimate is 34 weeks, which is almost double the most likely value. To calculate the duration, we use the PERT method. First, we add the optimistic estimate, 4 times the most likely estimate, and the pessimistic estimate, then divide the total by 6. So we get 14 plus 4 times 19 plus 34, divided by 6, which equals 20.67 weeks. Rounding this up, we get 21 weeks. This provides us with a relatively more conservative estimate compared to the most likely value of 19 weeks, allowing us to better account for potential delays and uncertainties, and better prepare for any unexpected setbacks. Now, let's briefly talk about a more advanced method, the parametric estimating method. The core idea of this method is to use historical data to create a predictive model for estimating the duration of activities or projects. Traditionally, these models are built using statistical techniques like regression, but recent research shows that machine learning can offer even more accurate estimates. These models uncover hidden relationships between project or activity duration and various factors, such as project location, type of work, quantity of materials, and even environmental conditions like temperature. Each of these elements plays a role in determining how long a task will take. One of the key advantages of this method is its accuracy, especially when reliable data is available. By considering multiple project factors and using real-world data, it provides more precise estimates compared to simpler methods. However, it's important to remember that the method's accuracy depends heavily on the quality of the data used. If the data is outdated or incorrect, the estimate may be inaccurate as well. Regardless of the method you use, it's important to remember that duration estimation is still an estimate. The actual duration may differ from the estimate due to various unforeseen factors. This is where contingency planning plays a crucial role. Schedule contingency is extra time added to the project schedule to account for potential risks. These risks could include unforeseen site conditions, such as discovering unexpected soil types, adverse weather conditions that delay progress, or design changes that require additional work. The contract duration is calculated by adding the estimated duration of the project to the contingency time. This gives a more realistic timeline that factors in uncertainties. As the project moves through the execution phases, the need for contingency typically decreases because risks become clearer and better management strategies are in place. However, time buffer still remains important to handle unexpected events until the project completion. So, who owns the schedule contingency? It is the contractor. The contractor is typically responsible for managing the schedule contingency. They must ensure that any risks are properly addressed, and the project stays on track within the allotted time. Alright, that wraps up this video, where we discussed the PERT method, the parametric estimating method, and the concept of schedule contingency. Thank you for watching, and we'll see you in the next video. Goodbye.